Good morning, children. We are in the next part of the chapter, metals and non-metals. In this part of the chapter, we would be discussing the uses of metals and non-metals. First is the use of metals. So the first part of the chapter is the use of metals. Okay, we would be starting the use of the metals. Under that, you see the first metal we are going to discuss is copper. The first metal we are going to discuss is copper. Copper has a symbol Cu. And another metal we have is aluminium, which has a symbol of Al. Both these metals are used in electrical appliances. Both these metals are used in electrical appliances because they are very good conductors. They are good conductors. And next, second thing is they have very less resistance. They are used as good conductors and they have very less resistance. So they are used as metallic conductors in electrical appliances. Okay. Next, another metal we have is iron. The symbol of iron is Fe. Now both copper, aluminium and iron, they are used as household utensils. Why they are used as utensils? Because they have a tensile strength. Next is they are shiny. Okay. Another important thing is that they are used to make factory appliances or factory equipments. In the industry, iron is used for the manufacture of equipments as well as it is used to make utensils for our day-to-day life. That is another important use of iron. Next is the use of iron. Iron is used as a catalyst. For the Haber's process. Iron is used as a catalyst in the Haber's process for the manufacture of ammonia. It is used as a catalyst, Haber's process for the manufacture of ammonia. After that, we have next metal, that is zinc. The symbol of zinc is Zn. It is used in galvanization. What is galvanization? Galvanization is a process in which iron article is coated with a layer of zinc. So that the article should not get corroded. Okay. Another use is aluminium. Another use is that it is used to make aluminium foils. Another use is that aluminium is used to make foils for the packaging as well as packaging of medicines, packaging of cigarettes and packaging of food material. Aluminium foils important use is packaging. It is used in the packaging industry. Okay. Next we have another metal, zirconium, whose symbol is Zr. Another important metal we have is zirconium, whose symbol is Zr. Zirconium is used for making bulletproof alloys. It is used to make bulletproof alloys. Okay. Another important metal we have is zirconium, whose symbol is Zr. It is used to make bulletproof alloys. Then we have lead metal, Pb. Pb is the lead metal which is used to make car batteries. Batteries, batteries. Okay. So these are some of the uses of metals. After that, we are going to discuss the use of non-metals. In case of non-metals, what are the first use? The first use of non-metals is that of hydrogen. Hydrogen is used for the hydrogenation of vegetable oil. Hydrogenation for the vegetable oil in order to make vegetable ghee. Next is hydrogen is used for the manufacture of ammonia, the same ammonia that iron was used by the Haber's process. It is used to manufacture ammonia by the Haber's process. By the Haber's process. This is another use of hydrogen. Liquid hydrogen is also used as a rocket fuel. Liquid hydrogen is also used as a rocket fuel. Next is carbon. Carbon in the form of graphite. One of the important allotrope of carbon is called as graphite. Graphite is used as an electrode. Graphite is used to make electrode, and another important use of graphite is that it is also used in some of the electrometallurgy processes. Next is nitrogen. Nitrogen is used for the manufacture of ammonia, manufacture of nitric acid, and also in the manufacture of explosives. Also used in the manufacture of explosives. Okay. One important use of nitrogen is the production of ammonia, production of nitric acid, and in the production of explosives like trinitrotoluene and trinitroglycerin. These two are explosives, okay? These are the basic uses of nitrogen, okay? Next we have sulphur. Sulphur, the symbol is S. It is used for the manufacture of sulfuric acid. It is used as a fungicide. Next is it is used to make gunpowder. Okay, it is used to make sulfuric acid, fungicide, gunpowder. Another important use of sulphur is in the vulcanization of rubber. Vulcanization of rubber. These are some of the uses of sulphur. That was all about the uses of some of the common nonmetals. See, many other uses are there, but these are the common nonmetals that we use. Okay children, the next part of the chapter we are going to discuss about chemical bonds. We are starting the next part of the chapter, chemical bond. Now the first question comes, why do atoms combine? The first question comes, why do atoms combine? Why do atoms combine? See, suppose I have a chlorine atom. There is another chlorine atom. Both these atoms combines and forms chlorine molecule. So these were the atoms and this is the molecule. So what I could see, or what I could say, that we had the chlorine atoms and these chlorine atoms are combining to form the chlorine molecules. Now the question arises, why should atoms combine to form molecule? What is the reason for them to change into the molecule? They could have easily existed in the atomic form. Now why should they combine? So the causes for atom to combine, first is to have a stable configuration. To have a stable configuration, the first cause is to have a stable configuration of the nearest inert gas. Of the nearest inert gas. Now the question comes that what is the configuration of an inert gas? Inert gases are actually those gases of the periodic table, that is those gases which are present in the last group of the periodic table, that is group 18. Inert gases are those gases which are present in the last group of the periodic table, and this is called as the inert gases. They are actually helium, neon, argon, krypton, xenon and radon. They are helium, neon, argon, krypton, xenon and radon. All these have 8 electrons in their outermost shell. Only helium has 2. So only helium has 2 electrons in its outermost shell. Actually helium has only one shell, and that shell actually contains 2. but the others, they contain 8 electrons in the outermost shell, and containing 8 electrons in the outermost shell, containing 8 electrons in the outermost shell, that is called the stable octet state. That is called the stable octet state. So what is the stable octet state? The stable octet state means having 8 electrons in the outermost shell. So all atoms, their tendency is to have 8 electrons in the outermost state, and that is called the octet configuration. So atoms combine in order to have a stable octet configuration, and that I have told you the first cause for a chemical bonding, and the first cause is that they should have a stable configuration, that is they should have the configuration of the nearest inert gas, or they should have 8 electrons in their outermost shell. That is the configuration they should have. Understood? Now next point is, whenever an atom combine to form molecules, they have lowest energy. They have the lowest energy or the maximum stability. Lowest energy or the maximum stability. So whenever atoms combines to form molecules, their tendency is to have the lowest energy or to have the maximum stability. Maximum stability means in the atomic state they are unstable, but when they form the molecule form, they get the maximum stability, and this maximum stability is the relevant condition that is needed for a chemical bond. Okay, so these are the two causes of chemical bond. Now, whenever a chemical bond is formed either by the donation of electrons or the acceptance of electrons. Now the question is, what is a chemical bond? What is a chemical bond? So chemical bond is actually a force of attraction. Chemical bond is a force of attraction that exists between atoms that bind them together. Suppose I have a molecule of water. This is the structure of water, right? So here what is happening, certain force of attraction is existing between hydrogen and oxygen by which they are bound together. I cannot separate the hydrogen from the oxygen so easily, neither can I separate the hydrogen from oxygen so easily. So in both the cases I would tell you that there is certain force of attraction that is existing between the atoms that bind them together. This force of attraction is called as the chemical bond. This force of attraction is called as the chemical bond. So what is chemical bond? It is the force of attraction that is existing between the atoms that bind them together in a chemical. Okay. Now this chemical bond are of two types. The first type is called ionic bond, or that is called as electrovalent bond, or that is called as electrovalent bond. It is called ionic bond or electrovalent bond. Now the first thing that we should know, what is an ion? So an ion is a atom or a group of atoms that has a positive or a negative charge because of loss or gain of electrons. So if I ask you what is an ion, you should say ion is an atom or a group of atoms that have either a positive or a negative charge because of loss or gain of electrons. Okay, so in this case, for example, we have an ion like Na plus, Ca plus 2, Mg plus 2, or we might have aluminium plus 3. In all these cases, what can I see? That they are having a positive charge. That in this case, sodium is having positive 1 charge, calcium positive 2, magnesium positive 2, aluminium positive 3. Or we may have ions like this: Cl minus, O minus 2, SO4 minus 2, N minus 3. So those atoms which has a positive charge, they are called as cations, and those which have a negative charge, they are called as anions. So I'm repeating once again, if the ions have a positive charge, they are called as cation. If they have a negative charge, they are called as anions. So in case of positive ion, the charge is positive. In case of cation, the charge is positive. In case of anion, the charge is negative. Now see, when a bond is formed by the combination of a positive ion and that of negative ion, then that type of bond is called a ionic bond. So I can say ionic bond is actually a combination of a cation plus an anion. I can say ionic bond is a combination of cation plus anion. So when a cation and an anion, they combine together, then the chemical bond that is formed because of the electrostatic force of attraction, that is called as a ionic bond. Okay, now suppose I have an atom like sodium. Sodium has total number of electrons 11, means 2, 8 and 1. Sodium's atomic number is 11. That means it has 2 electrons in the first shell, 8 in the second shell, 1 in the last shell. Now when as the sodium does not have a stable octet, now in order to have a stable octet, sodium will just give away one of its electrons. When sodium gives one of its electrons, it forms sodium plus, and that is, it gets the configuration of 2,8, and 2,8 is the configuration of neon. 2,8 is the configuration of that of neon. So just remember, as sodium has 11 electrons in the outermost shell, this sodium has in total 2 in the first shell, 8 in the second shell and 1 in the last shell. As it has 1 electron in the last shell, it does not have a stable octet. In order to have the stable octet, it will just give out one of the electrons and it changes into sodium ion. In the same way, think about Cl. Now see this chlorine. Its atomic number is 17. 17 means 2, 8 and 7. As we could see that chlorine is having 7 electrons in the outermost shell. That means what? It is having 1 less than that of the octet. So what it does? It actually accepts 1 electron that was given away by sodium. It accepts it and it actually forms Cl minus ion. So now the configuration of chlorine is 288. Now in this case, what is happening? We are getting the sodium ion and the chlorine ion. So now the sodium ion plus this chlorine ion, they combine and they form NaCl. In this way, the sodium chloride compound is formed, and this sodium chloride compound is bonded by a strong electrostatic force of attraction. This electrostatic force of attraction is called the ionic bond. Now the question is how to represent the ionic bond. So what we do, suppose I have the sodium atom. Now I will show the electrons of the outermost shell. See, I have told you sodium has 2 in the first shell, 8 in the second shell and 1 in the last shell. So we will represent it as sodium with 1 electron. So this dot represents the last electron in the outermost shell. Now in case of chlorine, it has 2, 8 and 7, or we can represent this chlorine as 7 electrons in the outermost shell. Can you just see the 7 dots in chlorine? Now what is happening? The extra electron that sodium was having, it is donating it to Cl. Because chlorine has a deficiency of 1. So in this case, it is forming Na plus Cl minus, it is forming NaCl. In this way, sodium chloride formation takes place. Now suppose I discuss the formation of magnesium oxide. See, magnesium's atomic number is 12. 12 means it has 2, 8 and 2 in the outermost shell. As it has 2, that means it is not having an octet. So it will always try to have octet. So it will give away 2 of the electrons and form magnesium plus 2. Now see, in case of oxygen, total number of electrons 8 means 2 and 6. So oxygen has a deficiency of 2. So it accepts 2 of the electrons and forms O2. Now in this case, what is happening? Magnesium plus 2 plus O minus 2, it forms MgO. It forms magnesium oxide. It forms MgO or magnesium oxide. So magnesium donates 2 electrons for magnesium plus 2. Oxygen accepts 2 electrons, oxygen minus 2. They two combine and form magnesium oxide. Okay. Now another reaction we can have is the formation of. Now how to represent this magnesium in a compound? So we can write it like this. Magnesium has 2 electrons in the outermost shell. Oxygen has how many? 6. So what will happen? Magnesium will donate its extra to that of oxygen. Hence it results in the formation of magnesium oxide. It results in the formation of magnesium oxide. Now if I say aluminium ion formation, aluminium's atomic number is 13, that is it has 2, 8 and 3. So aluminium will give away 3 of its electrons and form aluminium plus 3, and hence it will have a stable octet. Is this part now clear? So children, that was about the formation of ionic bond. Next part of the chapter we will discuss in next class. Till then children, goodbye. Thank you.